All right, so we talked about the fundamental theorem of calculus, and what we want to do is we want to look at the idea of from A to B. If we're given marginal cost and we're finding the integral, since marginal cost is the derivative of cost, the fundamental theorem of calculus tells us that this would be the cost at B minus the cost at A. So using this idea, we can figure out this would be the change in cost in changing from producing A amount of items to B amount of items. And so that's what we're going to use in this example. We're given data on the marginal cost of making certain t-shirts. And remember, marginal cost is defined as the amount of change, the amount our cost will change by in producing one more, in this case, t-shirt. So for part A, we want to estimate the total cost of making 60 t-shirts. And we're given the fixed cost is $100. And so if we want to remember first that total cost equals fixed cost plus variable cost. And when cost is linear, the fixed cost ends up being our y-intercept, and variable cost is the term that deals with our slope. Because when we're dealing with linear, slope ends up being a marginal cost. But when we have things more complicated, in the fact that we have a more complicated function, or in this case, data, we don't even know what the function looks like, we still have to think fixed cost plus variable cost. So in our case, we're given that this is $100. And what this is interpreted as 0, we want from 0 to 60 the integral of, our marginal cost, in other words, C prime, the integral of this would be our change in cost. This ends up being our variable cost. Because this is the amount of cost that has changed in making none to 60. Right. So with this in mind, they ask us in part A to estimate this cost. We have data, so all we can do is estimate this cost. So we're going to estimate the integral with Riemann sums. All right, so we were estimating from 0 to 60, so we have to be careful. We only care about the data dealing with from 0 to 60. And we're going to estimate, the best we can do is with Riemann sums using the data. We can do both a left and a right sum. You can choose one, or in the case of this example, I'm going to do both, and then we're going to average them. And so for the left sum, we're looking at all the data points that are at the left. So for 0 to 20, we're going to look at the 0. From 20 to 40, we're looking at the 20. And from 40 to 60, we're looking at the data at 40. So we have 3 rectangles, if I were to draw the graph, of 3 rectangles we're dealing with. And each of the width, so we're looking at using the terminology from before, the n would be 3, and the width, delta x, well, in this case it would be delta q, would be 20 for both of these sums. So the left sum, the first rectangle, would be 10, height 10, width 20. And then we have 4.67 times 20. And then we have 3.95 times 20. And we get that that equals 372.4. And the right sum, we're going to use the data. We don't use the 10, we use 20, 40, 60. Right? I mentioned before in an earlier video that for left sum we use all but the last one. In this case, all but the last one here. And in the right sum we use all but the first one. And so we're looking at these, the 20, 40, 60, as far as those columns. So we're looking at 4.67 times 20 plus 3.95 times 20 plus 3.58 times 20, and we get 244. And what I'm going to do is I'm going to average these. Right, so we're looking at 372.4 plus 244 all over 2. And we get maybe what some might consider a better estimate of 308.20. And so what our estimate for the integral from 0 to 60 of C prime is estimated to be 308.20. And that is actually the variable cost of making 60 t-shirts. So this is the answer to part B. So we ended up doing this a little bit out of order. And then the part A is the total cost of making 60 t-shirts would be the fixed cost plus the variable cost. And so for part A, we're looking at 100 plus 308.20. So my answer for part A, I'll write this up here, would be $408.20 as the estimate. Now for part C, we're asked what is the difference in cost in making between making 60 t-shirts and 100. And this for part C is notation-wise the integral of our marginal cost from 60 to 100. And so we're going to estimate this again with our left sums and our right sums. So we're going to estimate this. Again, we're looking from 60 to 100. And because of the data, we're really looking at, I'll mark these differently. We have n equaling 2. We have 2 rectangles. Width is still 20. And for this, our left sum, we're going to get, we're looking at 3.58 times 20 plus 3.33 times 20. And that ends up being 138.20. And for the right sum, we're going to get 333 times 20 and 3.15 times 20. Again, for the left sum, we're using these 2 data points. And for the right sum, we're using these 2 data points to determine the heights of the rectangles. And the right sum, when we add that up, we get 129.60. And when we average them, we're going to get an answer of 133.90. So the change in cost is in going from 60 to 100 t-shirts is $133.90. Notice we don't know where we started at as far as our cost. This just gives us the change in cost. We could have already had a total cost of $5,000. This is the change in these two production levels.